So we're going to talk about magnetic field now. It's a magnet. We're going to talk about magnets now. So let's start with the basics. A magnet has a north and a south pole. And what's happened is the north is going to be attracted with the south. Okay? So if I have the north pole here, I have a south pole here, the magnetic field is going to always travel from north to south. Okay, yep, like this. In ancient times, we use it. Even today, we use magnets to make compasses. And the Earth, the planet Earth, is basically a big magnet. So I gave you. Yep. Also remember that. Okay, about planet Earth. Say on Earth. Say this is Earth. We have a North Pole and a South Pole. Okay? But just remember, this North Pole and the South Pole is different. It's different than the magnetic north and south. Okay? So just remember, we call that the geography north and south. Okay? Just let me. Yep. This is the geography south. So if you have, well, what's happened in the ancient days when the ancient people, when they found a magnet, they use it. Okay? Now, the point that points to the north is called basically the north pole of a magnet. The point that points the south is called the south pole of the magnet. So basically, we know that the north is attracted to south. Okay? So basically, Earth as a magnet, okay, the geographical north is basically the magnetic south. Okay? So, yep. So our north pole is our magnetic south pole, and our south pole is a magnetic north pole. Right, magnetic north. Okay. So be aware of this. I don't want you guys to be confused when you're doing those questions. So on the planet of Earth, just always remember the magnetic field travels from the north to the south. Okay? On the surface, it travels from the magnetic north to the south, which is reversed. It's the geographical south pole to the geographical north pole. So, yep, this is really important. Okay? Just make sure you get this right. Okay. Now, basically, how do we measure magnetic fields? So the magnetic fields are measured in Tesla. It has a symbol B. B for magnetic field. Now, its strength is measured in a unit called Tesla. It's named after a scientist, Tesla. and there are some equations we can measure it. But let's worry about those equations later. What I want you to know now is try to try to understand that the magnetic field is actually in 3 dimensions because we live in a 3-dimensional world. So we try to learn how to label it. So the magnetic field can go from the left to the right, or the right to the left. Well, they can't be together, okay? Or it can be labeled with arrows from um, south to north, okay, from down to up, or from up to down. Okay, but also there are only 2 dimensions. Okay. The next dimension maybe is basically the magnetic field can come into the page or out of page. Okay. So here is a new symbol I want you to learn. So when I want to label a magnetic field, so I may do something like this. Okay, I draw 3 lines here. I tell you this is B. So you know I have a north pole here, I have a south pole here. Okay, because magnetic field, they travel from the north to the south. Okay. Magnetic attraction, they from north to south. However, sometimes I may write down something like this. Okay. A circle with a dot, that means out of page. Also a circle with a cross, that means into the page. So if I have a magnetic field labeled out of page, yeah, of course with a simple B on it, I know that the magnetic field actually came out of the page to my face. That's the direction of the magnetic field in this case. In the contrast, if I label that in this way, with crosses out into the page, it means the magnetic field actually is traveling at a direction from my face into the page. Okay. So in this way, this is how do we label 3-dimensional directions on a piece of paper. Okay. So you're going to dealing a lot with them in this chapter. Just be careful. Make sure you have them in your summary notes. Okay.